All right, here is a brief explanation of how rotations work, and specifically I'm going to be talking about rotating around the origin as the fixed point. We can also talk about rotating around a different point than the origin, and that's only slightly more complicated, but the theory is the same. And this is actually going to draw on what we learned recently, and the reason why we learned it is understanding slopes of perpendicular lines. So just as a reminder, the slopes of perpendicular lines are opposite reciprocal. Because here's why we're going to use that. So here we have a point, and that point has a coordinate 5, 2, and I've labeled it point A. And for this problem, we're going to rotate 90 degrees, and let's say we'll do it clockwise. So you remember a clock goes in that direction. So we know point A is going to rotate 90 degrees, and we think of it as, because it's a, so we're going to do that around the origin. So if this is the origin, you can almost think about it that it's sort of on a fixed string, and it's going to rotate 90 degrees. And thinking of that fixed string is useful because we can think of that line having a certain slope, and because it's going through the origin, the slope is really just y over x. I'm going to do that in a different color. So the slope of this line happens to be 2/5. Well, if it's going to go 90 degrees, 90 degrees forms a perpendicular. So we're going to be looking for something that is perpendicular like this. So it's going to end up along a line perpendicular, and so for that it's useful to know what the slope of this perpendicular line will be. Well, it's the opposite reciprocal, so it's going to be negative 5/2. And what that tells us is that the point, because we're rotating around the origin, is going to be down 5 and over 2. So it's going to end up right here, and that's the point to -5. So that we would label A prime. So that's how we rotated it 90 degrees. Now the one thing I want you to notice is if we compare 5, 2, which became 2, -5, a little trick is that what really happened was the x's and the y's flipped positions, and one of them became the opposite. So you can do a little logicking. I don't know if that's a word, but I'm going to use it right now. You can do a little logicking, and if you're looking at point A and you know it rotates 90 degrees clockwise, you know it's going to end up in quadrant 4, right? It was quadrant 4 down here. It started in quadrant 1. And if you know the 5 and the 2 are going to switch to a 2 and a 5, by logic, the 2 has to be positive and the 5 has to be negative. So that's another way of thinking about this. Okay, using that logic, you can rotate shapes around the origin, and really, the way you rotate a shape is just by rotating each of the points. So starting with A, if that's, oh, and let's just say we're going to rotate this one 90 degrees. Let's say counterclockwise, just so you can see another example. Around the origin. So point A is in quadrant 2. If we're going counterclockwise, that's going to go in that direction. And so we know point A is going to end up in quadrant 3. And the current coordinate is -2, 2. That's going to switch. And the 2 and the -2 are going to switch positions. Well, they're really just both 2's. And one of them's going to be negative. Well, the only way you can have a two 2's, it has to be right here. And that's going to be the point -2, -2. And we'll call that A prime. Okay, go to B. -2, 4. Switches to 4 and 2. And that's the point -4, -2. And -4, 3. Goes over 3, down 4. Let's see, that was... That's C prime. I'm getting a little confused there. That's -3, -4. And so there's our shape. And notice that in this case, you can see that it really did change the orientation. If it was pointing to the left here, now it's sort of pointing down here. And each of these rotations formed a 90-degree angle with the ending point. And so you could figure them each out by figuring out the opposite reciprocal slope of each one, or you could use my little trick of flip-flopping the coordinates, which is really just a shortcut for the perpendicular slope.